Good evening. Back in the shop again. Had one of my subscribers ask to detail how I do these project builds through a lot of, what shall I say, pain and suffering. I've learned the best way to do this. To start out, I had a drill bit set that went up to a 1/2 inch, which will fit most of your potentometers and switches, but not necessarily, say, a meter display. So I still use these for the pilot holes. I use the DeWalt's. The Milwaukee ones didn't seem to hold up well. Then I found I could get step drills. I believe I got these at Harbor Freight, 30-40 bucks for the pair. Definitely worth the money. This one I believe goes up to a 1/4 inch or 3/4 inch, and this one is 1.25 inches, I believe. It should be marked on here. 1 3/8. Anyway, every single hole I've had to drill with those has worked fine. To cut holes in the panels, I finally ended up getting a nibbler. I started out with a Dremel and a little saw blade, but boy, that made a mess everywhere. And I have a micrometer to measure the holes. Doesn't really help much. I usually use a felt pen and draw the outline and then cut inside the outline. That's basically what I use. So I don't have a new project, but I have one that I'm modifying. So this is going to be the same kind of project case that I used in the last video. The sheet metal place was charging me 30 bucks a piece to cut these, and I found a bunch of this stuff at the scrap metal place in a bin, and I bought a huge sheet of it. And my friend works in heating and air conditioning, and he cut them all down to size for 5 bucks. So a heck of a deal. So the reason I'm modifying this, the original display had just a volt and amp meter on it, and you couldn't, whatever the input voltage was what the display showed, but it was limited. So I went out and I bought this one, which is I want to say 0 to 100 volts and gosh, I think 30 amps, and it's got the watt meter in there. Unfortunately, when I went to install it, it was way too small for the hole. So I'm going to put another plate on the front, probably toss this one out, maybe turn the input plug sideways. This is for the current gain control. So I'll show you the project. This is a kit that I bought, I believe I got this out of Thailand or China, one of the two. Anyway, it comes with the little TO220 type FETs, but they don't go very high. And this is rated at 150 watts with just these. So under the heatsink, this came out of an old, gosh, I want to say it was a Sanyo. Anyway, under there I have IFRP 90-20s or something. I'd have to take it up and look, but they hold a heck of a lot of current, way more than this board will handle. So you have your 12 volts in. I just used like a hard drive power supply because it doesn't draw that much current for the LM 324. I got a 10-turn pot for the current so I can fine adjust it. Input jacks and a power LED on the front, and that's about it. But like I said, when I had the input, it would not go any higher than what was fed into the voltmeter. So I ordered this new display. The other adjustment that I made is this here that runs to the back, and I do have some cooling fans that run constantly when this thing's on. Anyway, I wanted to watch the ripple on the power supply I test when it's under load and see where it starts dropping out. So I added a little scope input. Most of the stuff I'm going to test on there is not going to be over 100 volts, so it's probably not going to be a problem with that. So I'm going to quit talking and start constructing this thing, and you can watch how I do it. I'll probably edit it for time, and then we'll put it together and I'll show you how it works. Alright, so I use, I guess this is 2-inch masking tape. I mask off the plate really well before I draw on it. I find it easier to do this and cheaper than use a felt pen. So on my, well, to me it's left-hand side, I'm going to go in 1 inch from the edge. Now on the case, you have to take into account the inset here, which is, I believe, about 3/4 of an inch. Some of the projects I had to cut the middle support part out, but just add an extra screw in the middle for support. So 1 inch up for the switch, 1 inch down for the power light. Switch hole is usually 1/4 inch for my mini SPDs or SPSTs. And then I want to go up 1 inch. You can change this, but I usually just do it for clearance. And I'm going to go in, say, 1.5 inches on this side for the control. Plate is 4 inches wide, so I will put the mark at 2 inches, which would be right smack dab in the center. 1.5 inches in, 2 inches for either edge. Now the input jacks that I use, where did it go? Anyway, the centers on the banana jacks are always 3/4 on a double plug. So I say 1.5 inches in, actually 2.5, and 3/4. Now these are the centers of the banana plugs, so I put a pilot hole in and then drill it out to 1/2 inch or whatever the spacer is. Okay, so now we need, see, they're getting these so close. I think I've got 2 millimeters on that side and 3 on this side. So I usually just stick this display where I want it to be. So this is 1.5 inches wide, supposedly. So I'm going to go up 1.5 inches. Another on this side. This will be my reference edge. And that's the hole I want to cut. So, quick tip, I got a hole punch and what I call my picture hanger hammer, and I start these with an indent to center the drill bit. Now don't be in a hurry like me, but I've got lots of practice doing this. Anyway, this will set your drill bits from wandering out. Another thing I use is C-clamps to hold this to the edge of the bench. So anytime I'm going to nibble a big hole, you need a 3/8 bit to enable the nibbler to get into the hole. That should be all the drilling I got to do. Well, except for the step bits. So let's do that real quick. So these are the banana jack plug or sockets that I use. Measurement shows center of the holes are 3/4 of an inch. Now when you panel mount these, they have an inset on the back. I believe it's a 1/2 inch, but I never have actually measured it. I don't know if you can see that. Anyway, I always cut my holes a little bit small, so if I have to enlarge it, I can. It looks perfect. Let's measure that just to see what size it is. I'll do it in, let's do it in inches. So that shows 0.4. Or just a little over a centimeter. Now measuring the outside of this shows 11 millimeters, or a little over 0.4. I'm going to go with 10 millimeters or 1 centimeter. Holes for the switches are always 1/4 inch, unless you're using a real heavy duty one, which should be a 1/2 inch. Now, LED holes, I actually wait to drill those until I have the LED, and then I can start small and work up until it fits tight. So we're going to hold off on that. Now my 10-turn pot, let's see what size that is. So just a little over 1/3 of an inch. Eight millimeters, 8.5. I know everybody doesn't have one of these, so what I usually do, and it works pretty good, is this is my 3/8 drill bit. Looks like it's going to be needed slightly larger than that. Or actually, that's a 5/16 drill bit. So probably a 3/8 would work. So I'll have to get the step drill out again. I'll use that one. Looks like I'm going to need to go in 5 steps. So I drilled 4 and stopped. And that's perfect. And that's why I stopped. Now this thing eats maybe a 1/16 of an inch at a time. And you can do corners or curves with it if you are careful. Bigger curves are easier, tight curves not so much. So now that that's done, I'm going to take the meter and see if it fits into the hole like it's supposed to. And perfect. Nice and snug fit. I start in, there's a couple tips I got for you. Start in with some primer. Sometimes I use automotive, other times not. Usually use 2 coats. One, you gotta shake the can at least a minute, preferably 2, to get the paint mixed correctly. Second, hold it a foot away minimum of the spraying area, what you want to spray. And I put this little block under one end so it's easy to lift when the paint's wet. I'll show you down here. This is in the vacuum tube lab. And you can see all my stuff. Some of this works, some of it's waiting on repairs. Anyway, I picked this thing up at a like a thrift store for $5. I was going to use it for a reflow oven, and I paint my stuff the same color blue, and I was having trouble with the paint. And one of the videos I watched, a guy in the comments suggested I read the HP Way, which tells the story of how Hewlett-Packard was founded. And when they first started out, they would use ovens to bake their paint on. Probably a lot bigger than this, but I thought, hey, that's perfect. So I started sticking my enamel front panels in there and baking them for 20 minutes at, where am I at here? About 200 degrees, 250. Let's see if you can see that. 20 minutes, and it comes out good. And the paint's much more durable than if you don't. So there's some tips for you. So I'm going to heat this up, spray it again, heat it up again, and then put some blue on it, and we'll bake it for 20 minutes. So blue paint on. And same temperature, but this time for 20 minutes. I'm not sure why, but the primer dries a lot faster than the enamel. So we'll be back. Alright, so we're back on the reassembly. A minute or two to get this stuff together. So what I've started doing when I install these, in order to access the holes for the wires, I'll put one of my screwdrivers in there and hold it in place while I tighten the nut on the back. Alright, ready to put the panel on. Alright, so we got power on down there. Throw the switch, power indicator comes on, display comes on, and the fans are spinning. Now we just need an input. We'll dial that down first. So one thing I've noticed about this display, even though it has a adjustment, it's not very accurate. So we're at 1.79 on the HP power supply, and this is showing 1.8. Okay, so I got this off the arm. This is our voltage in. This is our supply voltage, taking into account that all this crap's made in China, so accuracy is questionable. So let's crank the voltage up here a bit. We'll say 14.8, which would be a standard car stereo or something. Okay, current limit's all the way maxed, so let's start loading this down and see what happens. Third of an amp. Now for the case of watts, I'm going to turn this down to 10 volts. We can calculate it better. Okay, 10 volts. This is showing 9.7. And half an amp, 5 watts, give or take. I'll load this down some more here. We're at 1.5 amps roughly. Now this HP supply is only supposed to dump about 1.5 amps, so I think we're going to crash here pretty soon. Yep, there it went. Okay. So we'll go down to, say, 100 milliamps. And we'll crank this up. We'll go to like 30 volts or something. So over here, it's 29.5, so it's not off too bad. Our amperage rate is 0.12, and over here it's 0.16. Again, I can't sort of the accuracy of this. Let's go up to 3/4 of an amp. 22 watts. I'm going to hook up the scope and see what the ripple looks like. Bear with me. Okay, so over here I'm on channel A, I believe at 1 volt or 2 volts, 1 volt per division. Let me get this out right here. When I check for ripple, I usually go at least down to 0.5 volt or maybe less. Let's go to 1 milliamp or 1 millivolt. Yeah, it's not too bad. Of course, my camera frame rate's not helping any. Interestingly enough, this shows an amp of current draw, whereas this shows 0.8. Oh. I'll get on channel A. Yeah, a bit of noise in there. There is a fix for this on one of the builds for electronic loads. I believe it's a capacitor or two that you can hook across the LM324 and fix this stuff. So we're at 1.7 amps over here. So is 1.3. Oh, let's see our current limits going wacko again. We'll dial this up a bit. So where are we at? About a third of an amp. No ripple. This shows just under a third of an amp. Crank this up to half an amp. And the heat sink is cold as ice. So I'm thinking I need to get some heavier power supplies to test this thing out. Maybe I'll make a second video. Anyway, there you have it. This is my build with the modification. These, except for the heatsink, this circuit board is available on eBay. And I believe if you want to run this up to much higher amps, all you have to do is change the pass transistors, the FETs. And these resistors here are 0.2, which is your measurement for the current draw. So obviously this one here, I don't know if you can see this, 0.22 ohms, 5 watts. If you want heavier current, you're going to need probably a much higher wattage current load. Now on my meter here, they just have a little piece of wire down in there. Get out, see that thing. And I'm thinking that's probably why the accuracy is not that great. Anyway, gives me some more stuff to play with. Thanks for watching. Okay, so I'm gonna demonstrate this electronic load that we built in the last video. I'm gonna load down this ICO. It's a 1050 6 and 12 volt battery eliminator or charger. And I got the scope hooked up to the back of the power load so we can watch the ripple. We'll see if it does what I expect it to. So I'll turn this on first. And this is on the 6 volt scale. Well, this is supposed to go, let's see what it says down here. 0 to 8 volts at 10 amps continuous, or 0 to 16 volts at, let's say, 6 amps continuous. Alright, so we're full voltage here. So it's about 7, 8 volts on the scale. Over here it says 7.5, and I've got the load knob cranked all the way to the end, I believe. Yep. And we're loading it at 7.2 amps and about 55 watts. Now this is what our ripple looks like. And that's on a 2 volt per division scale. So I'm counting 2, 4, 6, almost 7 volts peak to peak ripple. That's quite a bit. You know, if you're charging a battery, I don't think that would really matter, but if you're using a, shall we say, a HF transmitter, that might be a problem. Alright, that's on the 6 volt scale, so let's turn this back down. Notice our voltage goes up. And this is supposed to be on the 6 or 0 to 8 volt scale. Now we'll go to the 12 volt scale. 27 volts. Alright. There's 1 amp. Nowhere near 12 volts. Let's crank this sucker up. Okay, so here we are at 82 watts, 7.2 amps. Let's see what, we can get this up to 12, where it starts dropping out. Just under 7 amps. Okay, so 7 amps. Over here it shows slightly over 12. And about 9 amps on the scale. Of course, these are analog, and if you've ever been inside one of these, there's absolutely no adjustment for it. And on the 12 volt scale, so over here we're now at 5 volts per division, and we've got pretty close to 1.5 sections. So I would say that's about 7 volts peak to peak. Now I wanted to show you this capacitor that I pulled out of here. This is rated at 20 working volts, 6,000 microfarads. You can see the crack going down the side from the over voltage. This was completely blown out. So yeah, I didn't even fire this thing up. I just replaced the capacitor. But I have worked on a lot of stuff, and I have never seen a capacitor explode like this. So next up we'll do a 1060. So now we're back with, this is a 1060S. Most of these are pretty all the same. This one has a slightly higher amperage output. Over here it says 10 amps on 12 volts and 20 amps on 6 volts. So let's see what we've got. It's set at lower 9 volts right now and 3.5 amps roughly. Ripple is nominal. So let's crank this up. We're on the 6 volt scale right now. The thing that concerns me about these, they dump a lot of current, but as you load it down, the voltage changes, so you have to stay on top of that. Seems to me you could easily fry some of your equipment. Now see there, at full amperage, on a 5 volt scale, we got about 5 volts ripple, maybe a little bit less. And I'm looking at this ripple, it's not defined sharply, so I'm wondering if this still has the old germanium diodes in it. Could be. So there's that one.